Good day, students and viewers. You are welcome to this video lecture. In this lecture, we are going to, in trigonometry and coordinate geometry, talk about addition formulas. Of course, the course is trigonometry and coordinate geometry. And we are going to talk about addition formulas. In addition formulas, we are going to talk about expressing the sum, the trigonometric ratio of the sum of two angles in terms of their individual angles, in terms of the ratios of their individual angles. So in this, we consider the diagram. So consider the diagram. Consider the diagram below. So let's draw the diagram. We have a right angle triangle. We have another right angle triangle. Okay, we have another right angle triangle. So here is a right angle triangle. And then we draw another right angle triangle. We have another right angled triangle here. Okay. Call this O, call here N, and call here M. Call here Q, and call this point P, and then name this point R. It is not difficult to see from this diagram that the angle here is P, Q, the angle QPR. So the angle QPR, I mean the angle at this place, is equal to the whole angle OPQ. OPQ is the angle OPQ minus the angle OPR. OP minus the angle OPR. But if you look at the angle OPQ, the angle OPQ, meaning this whole angle, in terms of this triangle, note that we are assuming these angles, call this angle A, call this angle B, and here we are talking about, let me just do something like this. So here we are talking about the sum of A and B, A plus B here. So we are assuming that A, B, and A plus B are all acute angles, are all acute. So that If A, B, and A plus B are acute, you see from this triangle, triangle POM, what we have is this place in terms of this triangle. So this is because in this triangle we are dealing with A plus B. It's a right angle triangle. So we are dealing with A plus B. And so this angle will be 90 minus A plus B. So A plus B. Also, the whole of this angle, in terms of angle B, the whole of it will be 90 minus B, because this is the triangle we have. Here is 90 and here is B, so the whole this angle will be 90 minus the angle B. So we can go ahead now and say, okay, so OPQ here is 90 minus 90 degrees minus B, because that is the whole of this angle in terms of this triangle. So minus this angle. So it is 90 minus A plus B. So you have 90 degrees minus A plus B. So that is it. So if you go, after expanding, 90 minus 90 will go. You have B minus B will go. And so you have minus minus A, which is plus A. And that is equal to angle A. So you are left with A. So now this angle is simply angle A. Here is A. Okay, so now we can, from the figure still, from the diagram, we have that sine A plus B. Where is A plus B? This is A plus B. This is angle A, this is angle B, and so here is A plus B. So we are considering this triangle, triangle PMO. So in triangle PMO, this is opposite over hypotenuse. And that, what is opposite? Opposite is PM over hypotenuse. The hypotenuse is OP. So let me just say MP over OP. But what is MP over OP? We can still break the line MP into MR plus what? RP. So this is equals to MR plus RP over OP. I'm talking about line segments. So maybe I can just be, let me be putting something like this to show line segments. Line segments, okay? But this MR is the same thing as NQ because they are of the same length. So I can replace MR with NQ because they are equal. So I can just go ahead and say this is NQ plus the line RP. For easy evaluation, let me use just the lines without noting the segments. I'm sorry about that. So let's go. This is over OP. We all know we are talking about line segments. So This is over OP. So initially I have MR over, I have MP over OP, but MP is MR plus RP. But MR is equals to NQ. So I can write something like this. I can now split, because this is a common denominator. This is NQ over OP plus RP over OP. Okay. So now, you see, if you have this kind of thing, if you have NQ over OP, you can multiply it by any line and divide by that line. You can multiply it by OQ over OQ. So it's still the line NQ over OP, because OQ over OQ, the answer is 1. So multiplying any line segment by 1, the answer is just the ratio of that lines you have. So I can multiply this by the line OQ. So I can say NQ over OP times OQ over OQ plus I can now multiply this by, I can say RP over OP times QP. So I can say QP over QP. So with this, I can say this is equal to, I can write NQ over OQ times OQ divided by OP. So that if OQ should cancel OQ, all I have is NQ over OP, which is my initial line. Okay, so this is plus. Here is RP over OP, RP over, let me write RP over QP times QP over OP. But what is this? Now NQ over OQ is what? So I have NQ over OQ. That is opposite over hypotenuse of A. But that is sine A. So that is sine A. But what is OQ over OP? So OQ over OP. So in terms of B, that is adjacent over hypotenuse of B. What is adjacent over hypotenuse? That is cos B. Now plus RP over OQ. This is RP over OQ. That is adjacent of A over adjacent over, so that is RP over OP. Okay. RP over QP, yeah, that is RP over QP. Where is RP over QP? That is adjacent over hypotenuse of A, that is cos A, times what is QP over OP? QP, this is QP over OP, that is opposite over hypotenuse of B, and that is sine B. So all I have is sine A plus B is equals to sine A cos B plus cos A sine B. So now I can express this ratio, the trigonometric ratio of the sum of A plus B, as the sum of the products of the individual of trigonometric ratios of A and B. Okay, still from the figure, I have what is cos A plus B. Cos A plus B is adjacent over hypotenuse of A plus B. So the adjacent is OM over hypotenuse, which is OP. So this is equals to OM over OP. The line segment OM over the line segment OP, because this is A plus B. And we are considering triangle PMO or triangle MPO. Yeah, okay. But if you look at this OM, it is ON minus MN. So this is equals to ON minus MN over OP. But if you look at MN is RQ, so I can replace MN with RQ. So this is equals to ON minus RQ over OP. Okay. So what is, so I can now separate. I can say ON over OP minus RQ over OP. Common denominator, so I can separate. What do you have? So you can still do as we did in the previous sine version. So you divide and multiply by OQ, so that you have ON over OQ. So I will just go direct over OQ times OQ over OP minus, so you divide by this line, so you have RQ over QP, is QP times QP over OP. But what is this? ON over OQ. What is ON over OQ? ON over OQ. That is adjacent over hypotenuse of A. That is cos A. What is OQ over OP? This is OQ over OP, but that is adjacent over hypotenuse of B, and that is cos B. Minus, what is RQ over QP? This is RQ over QP. That is opposite over hypotenuse of A. Opposite over hypotenuse, this is sine A. Now, what is QP over OP? So QP over OP, that is opposite over hypotenuse of B, that is sine B. So therefore, what we are saying is cos A plus B is equals to cos A cos B minus sine A sine B. So you can give this equation, call the former equation 1, call this equation 2. Remember, the channel name is Gwagoda Mathematics Class, and we are in trigonometry and coordinate geometry. We are treating addition formulas in this lecture. So remember, we have from 1, we have sine A plus B is equals to sine A cos B plus cos A sine B. So this is 1 and that is 2. Now, replacing B with minus B in 1, what do you have? So wherever you see B, put minus B there. So we have sine A minus B, because B is minus B here, is equals to sine A cos minus B plus cos A sine minus B. So you have sine A minus B to be equal to, this is sine A, because this is sine A. Cos minus B is equals to cos B, remember, as it's an even function, and so this is equals to cos B. But sine minus B is minus sine B, so the minus will affect the whole product here. It will be minus cos A sine B. Call this equation 3. Likewise, replacing B with minus B in 2, we have, so we obtain cos A plus B, so here is minus B. This is equal to cos A cos minus B, and that is cos B already. So cos A, even if B is minus, is the same thing as cos B minus here. So this is sine A sine minus B. So the minus, if you put minus B here, the minus will affect this minus, it will be plus here. And this is equals to sine A sine B. Call this equation 4. So that is it. Now we have equation 1, 2, 3, 4. These are addition formulas for sine and cosine. Now, what is the addition formula for tan? Okay. So what is now tan A plus B? But tan of any angle is sine of that angle over cosine of the same angle. So that is equals to, you have, this is sine A plus B over cos A plus B. But you have your cos A plus B there from equation 1 and equation 2. So what you have is what is sine A plus B? This is equals to sine A cos B plus cos A sine B over, what is cos A plus B? This is equals to cos A cos B minus sine A sine B from equation 1 and equation 2, or equations 1 and 2. Now we need, so dividing both the numerator and the denominator by cos A cos B. What do you have? Dividing the numerator and the denominator by cos A cos B. What do we have? You have tan A plus B is equal to, prefer to use, okay, tan A plus B, this is equal to, so you divide here by cos A cos B. What do you have? So you have sine A cos B over cos A cos B plus cos A sine B over cos A cos B. This is the numerator, and I have division for this division line. So the denominator is, this is cos A cos B over cos A cos B. What do I have? So minus sine A sine B over cos A cos B. So this is equal to sine A, this is cos A cos B will cancel. What you have is sine A over cos A plus, what you have here is cos A will cancel cos A, so you have sine B over cos B all over, so this division line is now this. So now cos A cos B over cos A cos B, the answer is 1. So I have minus, this is sine A over cos A, that is sine A over cos A times sine B over cos B. So what is that? So clearly this is equal to tan, so this is equals to tan A. Sine A over cos A is tan A plus sine B over cos B is equals to tan B over 1 minus sine A over cos A is tan A. So this is tan angle A times tan angle B. So because sine B over cos B is tan B. So therefore what you have in a nutshell is that if you have tan of A plus B, the answer is equal to tan A plus tan B over divided by 1 minus tan A times tan B. So I don't know, maybe you can give this equation 4, you can give this equation 5. Okay, let's see. We have an example. Okay, the example is saying, find the sine cosine and tangent of angles 75 degrees and 120 degrees. Solution. We are starting with sine 75 degrees. But you see, we can always express 75 as, so that you have sine as the sum of 30 and 45 degrees. So sine 75 degrees, this is equals to sine 45 degrees plus 30 degrees. And it is not difficult to see that we have already done it, that if you have 45, here is 1, here will be equals to root 2, so that sine 45 will be equal to opposite over hypotenuse 1 over root 2. Likewise, this is equals to cos 45 degrees. It will be just 1 over root 2. So what is tan? Tan 45 is always equal to tan 45 is always equal to 1. So if you have 2, and you have 2 here, so here you have 30 degrees, sorry, here you have 60, here you have 30, so here will be 1, so here will be root 3 over 2. So you have sine 30 will be equals to opposite over hypotenuse, which is 1 over 2, and that is equals to cos 60 degrees. And you have sine 60 will be equals to opposite of 60, this is root 3 over 2, divided by, sorry, so here is 1, here is 1 over 2, let me take it like that, here is root 3 over 2, so that sine 30 is opposite over hypotenuse, that's 1 over 2, correct? And then sine 60 is opposite of 60, root 3 over 2 over hypotenuse, so it is equals to root 3 over 2, and that is the same thing as cos 30 degrees. Okay, we can now go ahead. But what is tan? Tan 30 tan 30 degrees is equal to, okay, tan 30, that is opposite over adjacent. That is root 3 opposite over adjacent times 2, and that is equals to root 3. So tan 60 is root 3, while tan 30, then tan 30, tan 60 will be 1 over root 3. Okay? So what we are saying here is, so this is 45 plus 30. And so, but by equation 1, this is sine 45 cos cos 30 plus cos 45 sine 30. But this is equal to sine 45. From there, sine 45 is 1 over root 2 times cos 30 is 1 over 2 plus cos 45. Cosine of 45 is 1 over root 2 times sine 30. Sine 30 is root 3 over 2. Sine 30 is cos 30 is root 3 over 2. So root 3 over 2. Cos 45 is 1 over root 2 times sine 30. Sine 30 is 1 over 2. Good. So all I have is, here is root 3 over 2 root 2, because if I multiply root 3 times 1 is root 3, 2 times root 2 is 2 root 2, plus 1 times 1 is 1, 2 times root 2, I have 2 root 2. So I can say common denominator now 2 root 2, so the answer is 1 plus root 3 over 2 root 2. So this is it. What about cos 75? Cos 75 degree is the same thing as cos 45 degrees plus 30 degrees. And that is equal to, so this is equal to, by addition formulas, so that is cos 45 cos 30 minus sine 45 sine 30 degrees. But what is cos 45? Cos 45 is 1 over root 2. What is cos 30? Cos 30 is root 3 over 2. So I have root 3 over 2 minus, what is sine 45 is 1 over root 2. What is sine 30? Sine 30 is 1 over 2. So I have, what I have is, I multiply, I have root 3, so this is equals to root 3 over 2 root 2 minus root 1 over 2 root 2. I have 1 over 2 root 2, and that is equal to, so 2 root 2, 2 root 2, so I have root 3 minus 1 all over 2 root 2, common denominator. So you see, this root 3 is here, and then minus 1. So the root is only affecting 3, not minus 1. So what is tan 75 degrees? So this is equals to tan 45 degrees plus tan plus 30 degrees. But that is by equation number 5, that is equals to tan 45 degrees plus tan 30 degrees, okay, over 1 minus tan 45 tan 30 degrees. So this is equal to, so tan 45 is 1, so I have 1 plus tan 30 degrees. Tan 30 is root 3. That is root 3. So over 1 minus tan 45 is 1 times tan 30 is root 3. That is equal to tan 30 is opposite over adjacent. Tan 30, there's a mistake here. Tan 30 is opposite of 30 over adjacent. So that is 1 over 2 times 2 over root 3. So you cancel. So you have 1 over root 3. Tan 30 is 1 over root 3. I hope I've not used tan 30 anywhere. Tan 30 is 1 over root 3. So that tan 60 is root 3. This tan 60 that is equal to root 3. Okay, so this is equal to, so you find a way of adding this, and that is you have the LCM to be root 3, and that is you want to multiply by root 3, you have root 3 plus 1 over root 3, so you have root 3 plus 1 all over root 3. That is and then you have times, because it's a fraction, here I have 1 times 1 over root 3, the answer is 1 over root 3. So I have here to be root 3 over root 3 minus 1 over root 3. So I have root 3 here as the denominator because of the multiplication here, and I have 1, so I have root 3 minus 1. So root 3 will cancel root 3. What I have here is root 3 plus 1 over root 3 minus 1. So that is the tan function of 75 degrees. So we have tan, so you have the second angle, which is 120, but I will not solve. I will allow students and viewers to solve that as an easy exercise. So if you are finding sine 120 degrees, this is the same thing as sine 120 sine 180 degrees minus 60 degrees. You can as well say 120 degrees is equals to 60 plus 60 degrees and then solve. But we are reserving this in the next section of our lecture. So you can easily solve this. Likewise, the tan, the cosine and the tan of 120 degrees is the same thing as cosine of 180 minus 60 degrees. For the sine 120, for the sine of 180 minus 60 degrees, this is very simple. This is sine A, which is sine 180 times cos 60 minus, so sine 60, this is cos 60 degrees sine 180 degrees. So because so actually we know that the equation is sine A plus B is equals to sine A cos B minus, so this is plus cos A sine B. So actually here is minus, so this is how to go about it. And for the cos function of 120, that is 180 degrees minus 60 degrees, so this is equals to cos 180 times cos 60 degrees minus sine 180 sine 60 degrees. If you evaluate this, these are the respective sine and cosine. For the tan of 180 minus 60 degrees, this is equals to tan 180 degrees plus tan 60 degrees over 1 plus tan 180 degrees tan 60 degrees. This is left as an easy exercise for students and viewers to evaluate. Please subscribe to our YouTube channel and like our videos. Also share our videos with your friends so that the videos can reach to more audience. Thank you.